So here's the same binary search tree, and we already showed that it's a valid red-black tree. But is it a valid AVL tree? Let's take a look. So remember an AVL tree in an AVL tree, every single node has to have a balance factor of -1, 0, or 1. So let's go ahead and fill in all of the balance factors. Remember, leaves are fairly simple. They all have balance factors of 0 by definition, because their right and left subtrees are empty. Okay, now let's go for internal nodes. So this node 50 has 1 minus 1 is 0. Here we have 1 minus 2 is -1. Here we have 1 minus 1 is 0. 2 minus 3 is -1. Let's go to this side. 0 minus 1 is -1. 1 minus 2 is -1. And then 1, 2, 3, 4, because remember I have to take the longest path. 1, 2, 3, 4 minus 1, 2, 3 is 1. So in this example, every single node does indeed have a balance factor of 1, -1, or 0. So this specific red-black tree also happens to be an AVL tree. Let's take the same exact red-black tree, but let's slightly modify it this time. Specifically, let's pretend this node doesn't exist. Let's just remove this specific node. It was a red node, meaning it did not have any impact on the number of black nodes along any given path. So we're guaranteed that it does not impact our red-black tree. And if you want to help kind of confirm that, let's take a look. So before, the number of black nodes along any given path as they went through this one would be 1, 2, 3, then nothing else. 1, 2, 3, nothing else. 1, 2, 3, nothing else. So by removing this node, we have not impacted our red-black tree properties. So this is still a red-black tree, even if I deleted this node. But now that I've done this deletion, I've just wiped out this node. Is the resulting binary search tree, which is a valid red-black tree, is this one also a valid AVL tree? Let's take a look. So again, we have to fill in our balance factors. So leaves are easy. They have balance factors of 0 because they have empty right and left subtrees. So I'll fill those in. Okay, now for the internal nodes. This one's balance factor is 1 minus 1, which is 0. This is 1 minus 2, which is -1. This is 1 minus 1, which is 0. This is 2 minus 3, because I have to take the longest path. So 2 minus 3 is -1. This node is 1 minus 1 now, because I've deleted this node. 1 minus 1, which is 0. And this is 1, 2, 3, 4 minus 2. So 4 minus 2, this is 2. So this binary search tree has a node that has a balance factor of 2. So this is not an AVL tree. Even though it's a red-black tree, it is not an AVL tree.